So in this video, we're going to talk about how to solve an exponential equation using logarithms. So in the last video, we talked about these 3 log rules, which kind of allow you to condense. If you have 2 logs that are being added together and they have the same base, you can combine them with multiplication. If it's subtraction, combine it with division. And remember, if you have an exponent here, you can move that exponent down to no longer be an exponent in front of the logarithm. Or if you have it in front of the logarithm, you could pop it back up if you wanted to. So just depending on what you're trying to do. This power property in particular is going to be really helpful. So let's think, can we solve these for x? On the first one, yeah, x just needs to be 2 because 5 squared equals 25. On this one, since they're both just 5s, if I wanted to solve for x, all I would need to do is set 3x minus 2 equal to x, and then I could do some algebra and just solve for x. So far, nothing that crazy. On this one, I have no idea. I mean, 5 to what power gives me 7? I mean, 5 to the first power is 5. 5 to the second power is 25. So the answer is going to be 1 point something. But how do we find exactly x? How do we undo the 5, basically? How do we get x to not be an exponent? Because I can't solve for an exponent. I can't just divide by 5 because that's not multiplication. It's to the power of x. So to solve for something like this, to solve for a variable as that's an exponent, you need to use logarithms. Here's kind of the steps if you want to jot these down. To solve an exponential equation, make sure you have the base and exponent alone. You might need to solve for just the base and the exponent. Then take the log of both sides. As long as you do it to both sides, you keep it balanced. By the way, you can use any log you want. Usually I use log base 10 because it's in the calculator, or natural log because it's in the calculator. But you could do log base anything, it really doesn't matter. Then you can use the power property to bring down the exponent and solve for x. So here's what I mean by that. That might not make a whole lot of sense right now. Imagine I want to solve this for x. Again, I could guess around and just try different values of x until I found like a decimal that's kind of close. But the easiest way to do this is just do the log of both sides. I'm taking the log of both sides, and it's as long as I do it to both sides, it stays balanced. Now we're going to use that power property, which says I can bring this exponent down to no longer be an exponent. So now I have x times the log of 3 equals the log of 17. We don't really need parentheses there. Now that it's no longer an exponent, I can solve for x very easily. It's being multiplied by log 3, so divide by log 3. And there we go. Now I have x. It's this. I'm going to need to type that in my calculator. If you have a TI-84 or even like a phone calculator, if you just turn it sideways, there's a log button. Again, this is why I didn't use log base 5, is because log base 5 isn't in the calculator, but log base 10 is. Or you could also have used natural log. So just type this in. Be careful when you type it in. Do log of 17, and you're going to need to make sure you close the parenthesis and then divide it by log of 3 and see what you get. And that is about 2.5789. It keeps going, but that's the gist. And so if you did 3 to the power of about 2.6, it would be close to 17, but not quite. Again, just to refresh, it all hinges upon you need to have logarithms, because if there's logarithms, you're allowed to just bring the exponent down. And so that's how we can solve an exponential function. On this one, before I start trying to take logarithms, I need to do step 1, which is get the base and the exponent by itself first. This plus 3 needs to go. So just like you do with any algebra, just move it to the other side, and that leaves me with 78. Now I have the base and the exponent by itself. Now, since I need to bring this exponent down, I'm going to do the log of both sides. Log here, and now I can bring this down to the front. Be careful, because it all comes together. So this is going to be 2x plus 10 times log of 9. Just a reminder, the log doesn't exist by itself. It is attached to that 9. So I can't be just like dividing both sides by log, because log doesn't exist by itself. It's a parasite. It has to be latched onto something. Just like square root doesn't exist by itself. It has to have something in it. Same thing with logs. So don't try to just put a random log somewhere. All right, if I want to get x by itself, the first thing I need to do is divide by log 9. The whole thing, not just log, but log 9. Log of 9. That will cancel out with this. And since it was multiplication, I divided. You can go ahead and put that in your calculator if you want. I'm going to go ahead and keep going though. So now I'm left with 2x plus 10 equals log of 78 over log of 9. I'm not going to do this yet because it's going to be a irrational number and I don't feel like writing all those decimals just yet. So I'm going to need to subtract 10. And then I'll need to divide by 2. And then divide this by 2. So now I can type all this into my calculator. Divide those and then subtract 10 and then divide by 2. So log of 78 divided by log of 9, then minus 10, and then divided by 2. And I got -4. It has a few decimals, but about -4. All right, and again, if you were to plug in -4 here, it would be close, maybe not quite, but it would be just about 81. All right, let's try one with an e in it just for fun. Remember, e is approximately 2.7. It's in your calculator if you need the e button, and it pops up a lot in exponential stuff. Again, before I try to solve this, I need to get the base and the exponent by themselves. So get rid of the -1/2. The easiest way to do that would be multiply by -2. Because 2 and a half cancel and negative cancel. So that just leaves me with e to the 2x equals 50. Now, I want to bring this exponent down, so I'm going to need to do the log of both sides. Kind of an easy way to do this one, since it already has an e, would be to use a natural log. You don't have to, but you could do a regular log like we were doing before, but natural log is nice because natural log and e actually just cancel out and leaves 2x. And then just divide by 2. Remember, there is a natural log button in your calculator as well, right below log. And then divide by 2. And so x is about 1.956.